Okay, this hangout is live. What does it say, Lady Ada?
We're on air, as you can tell.
Yeah.
It's our weekly hangout. Welcome to a weekly show and tell hangout that we do here on Google+. It's me, Lady Ada, and you, the fine audience, who are showing off your maker, hacker, projects, electronics, 3D printed, laser cut, robotronics, retro tech, and Radio Shack memorabilia. We will have more people show up, but want to start with...
We're going to go to Tony, Noah, and Pedro, then Chris, and then Alex.
And then Greg.
And then Greg.
And then whoever else shows up.
Yep.
We have to be out of here. You have to be out a little bit earlier. So
yeah, there's YouTube live update stuff I got to work on.
YouTube live's iffy, so if we could finish up at 7:50, that would be like so awesome.
Yeah.
It would make our lives a lot easier.
All right, Tony, go for it.
Go, Tony.
Hey, yeah, so last week I was showing off the BNO055 Absolute Orientation Sensor, making it work with the Raspberry Pi, and I was running into some problems, and I'll show real quickly. So luckily I kind of overcame those problems and sorted out some of the issues. And let me screen share here. So let's see. Let me know, do you see the screen?
Yeah.
Yep.
Okay, perfect. So the big problem that I was running into is that the sensor uses I2C clock stretching, which is a way to kind of communicate between two I2C devices. It's a little bit uncommon. Like one device kind of holds the clock line a little bit longer to acknowledge something's sent or not. And the problem is, unfortunately, the Raspberry Pi doesn't really support clock stretching. There's a well-known bug where Gert Van Loo, who's the hardware designer behind the Raspberry Pi, actually realized and acknowledged that, yeah, it doesn't. There's a bug. It doesn't support it well. There are some weird workarounds you can do, so you can slow down the I2C bus to like 10 kilohertz. Normally it's 100 kilohertz, and then it sort of works. But luckily, the sensor, the BNO055 sensor, it also has a UART mode, where you can use it as like a serial device. And so you just have to pull one of the pins to a high level and it'll switch into UART mode. So I wrote the library to work in both the UART mode and the I2C mode. Now in this case I've got it working with a BeagleBone Black, and luckily the BeagleBone Black works perfectly with I2C clock stretching. So this is just hooked up and using the I2C mode. The other issue that I ran into is that you need to calibrate the device. And so on the right here, you can see this is a web page, and it's got a 3D model. This is actually the MOSFET chess piece little model. And you can see in the bottom right here the calibration data. And so this is showing the sensors on the board, the gyroscope, the accelerometer, and the magnetometer. Each one has to be calibrated before you can get back good orientation data. And so there's an interesting process I'll run through here. So the magnetometer, you kind of have to move in like a figure 8 kind of pattern for a little bit here. So I'll move this around, and you can see the value going from 0 up to 3, and 3 is fully calibrated. So in a second here we're at 2 on the magnetometer. We should jump to 3. So okay, so we're at 3, so the magnetometer is calibrated. The gyro, luckily, it calibrates pretty easily. It pretty much self-calibrates instantly. Now the accelerometer, you have to move it through like 6 different planes, and you hold them there for about 2 seconds each. So I'm moving it between like 45-degree angles and just kind of holding it here. And usually once I do like a full rotation, so you can see it's kind of halfway calibrated, and it's slowly getting there, and then maybe if I go down to here. So okay, so now the accelerometer is calibrated. Now the fun thing, so we're pretty much fully calibrated as far as all the sensors go. The annoying thing is the system isn't calibrating yet, and this is like the sensor fusion algorithm itself. So that's kind of what I'm dealing with now, is just trying to figure out why all the sensors are calibrating, but the algorithm isn't calibrating. But you can at least see, so when I rotate this like left and right, the cat's rotating, just in the right direction. The other fun thing is sorting out the angles or the axes. So on the sensor, as I rotate it this way, you can see the cat's kind of rotating the wrong way, and that's because on the BNO sensor, the z-axis is actually going up, whereas on your computer monitor, the z-axis is kind of the up-down axis. So there's some axis remapping that I need to do here to kind of sort it out, but getting a lot closer than I was before. So I can at least see things rotate, and you can kind of see the system. It jumps into calibration sometimes and sometimes not. So a little more progress, luckily. I think we're pretty close to getting it all sorted out. But at least I've learned a lot about kind of the sensor here and how to calibrate it in the process. So just a cool thing to be aware of if you're using the sensor, that definitely read the data sheet and see how to calibrate it so you go through the process to get good values.
Just like they're using the models from the Adafruit Circuit Playground chess set as the virtual things that you're moving around. It's perfect.
Right, so there's the bunny model that we use with the processing sketch, but I figured it's time to kind of mix things up. Let's use a cat model here.
It's time for MOSFET.
Yep.
All right, thanks so much, Tony.
Thanks, Ed.
All right, Noah and Pedro, what you got cooking this week?
Hey, what's up, everybody? This week, Pedro, you got a cool project. Last week you were showing us this.
Yeah, so this just went live, I think, yesterday. So all the files and the learning guide is available. And good thing we have to build 2 for doing the video and the photography,
Sure.
because last week I said that it did work on the camera. I guess I had like a faulty display, because on the second build, oh my God, it works perfectly. It's a giant, this camera display that'll work also on your laptop and, of course, Raspberry Pi.
Very cool.
And if we can focus in here, you can
Okay.
kind of see what.
Oh, yeah, so
project you're working on.
this is another project I'm working on, collab with Phil B. This is the D20. It talks. I turned it off. I probably should have turned it on, but you can open it, and if I can open it, there's like magnets and stuff to keep it together. But speaker, accelerometer, pro trinket. Thank you. Battery. It's rechargeable too, because it's got the light poly backpack. We'll talk more about that a little bit later, but I do want to mention that this week, chess set. I hope you didn't break it.
No.
Chess set is happening this week, and we're pretty excited about it. I hope you guys are too. Tomorrow we're going to talk more about that and more about
New
some
printers
other
we're
things.
testing out,
Sure, the
yeah.
printers, more materials and things, and ooh, kitty cat, cat in the box. That's all we got, guys. I'm rambling.
And once you start looking at the cat in the box, you know you're done.
Oh, yeah.
Yeah, we're gonna get into chess fever here soon at Adafruit. So for the chess fans out there, we'll have some cool things, and I think people are gonna like it. We want people to print out chessboards and play chess. And,
Oh yeah, you're ready to game on.
Yeah, and look up Judith Polgar. She's an amazing chess player, and she beat Kasparov and Magnus. So I'm trying to learn some moves from some of her stuff. So I want to channel my inner Judith. Okay.
Thanks, guys.
Okay. Next up, Chris, unmute your mic and show us your project.
Hey, Chris.
Can you hear me?
Yeah, sound great.
Okay, well, I had my 60th birthday on Sunday.
Happy birthday.
So I bought me an extravagant present. Some guys buy sports cars. I bought a printer, bought Metal Plus. And so I want to show you some of my failed prints, because I'm an idiot when it comes to 3D printing. Just like everyone is at the beginning.
Turns out 3D printing companies are idiots when it comes to 3D printing companies too. Don't worry about it.
Yeah. Well, anyway, I wanted to print Adabot, and this was the head, and I didn't have support turned on. And of course, when it tried to jump the gap across his mouth, it didn't do too well, and the print head caught the corner of the mouth and knocked it off the plate.
Okay.
So it didn't work. Do the next one, Dad. Go ahead, Dad. This one I printed with the face down. Still didn't know that I needed to turn supports on. I thought they were already on. And I was going to Skype with a friend to show him my new 3D printer. And the driver on my document camera crashed Skype, crashed my computer, and of course crashed the print. So there's failure number 2. Next one. This one, I had the supports turned on, but not the supports within the object. And so when it tried to close the neck hole, the same thing happened. It got a little bent corner, the print head crashed into it, and ruined the print. And then finally, the 5th time's the charm. I've got this one done. I had to switch colors of plastic because I was running short of the light green. But at least I got that far. I've not yet printed his legs. That's going to be a 3 or 4 hour job. And we've had a lot of thunderstorms around here the past couple of days. So you don't want to start a 4-hour print in the middle of a thunderstorm. I am smart enough for that. While I had the clear plastic in for the eyes and the mouth, I started printing a TARDIS pendant, but it was with the plastic that came with the printer, and it's not on the spool. And so it's just a loose coil of filament, and it got all tangled up, and we couldn't get it untangled, and the filament broke. So that one failed. But I did finally get a full window for the TARDIS. So now I got to do is print the other pieces and go from there. So I'm having a lot of fun with it. I've only had it a little over a week.
All right.
Well, it's cool because you've done so much 3D modeling that now you're like, all the 3D modeling that you've done with Pavre, you're like, I can make it physical.
Yeah, Pavre will not export its primitives as a mesh, but I'm going to try using some of these programs where you can take a series of pictures and it will figure out the shape of the object by just ray tracing my figures from different angles. So I have like 20 different ray tracings, all from a different angle, and plumb it through some software, and it'll create a mesh for me.
Okay.
So if I get that working, I'll show you next week.
Yeah, I was going to say, come back with more of your 3D prints, and your printer can get an as seen on the Show and Tell sticker. Send us an email, support@adafruit.com, and you can affix it to a non-heated part of it.
Okay, I'm going to start up a print here.
All right, we're printing cats on this side, and then we got print started here. Okay.
It's super chill. She has like a paw outside.
Alex, how's it going? Speaking of 3D printing, what you got this week?
Hey, good. How are you guys? I've got some interesting things with prosthetics, actually. So I think it's kind of an interesting thing that everybody's been really trying to do a lot of like robotic hand projects, and find that it's kind of difficult to do a lot of points of articulation with fingers, and kind of trying to replicate that when you have kind of a limited input control of what you can do with a prosthetic. So this is something, this is kind of a funny thing we did this week. This is unrelated, but this is a cool 3D printing project. There's actually a play going on in downtown Detroit, and one of our people in our kind of a co-working space, Tech Town, they needed, their main actor needed a kind of prosthetic limb, so set in like the 1940s or something. So you end up kind of having this, you know, just simple claw thing. And this whole big body is printed out of Ninja Flex, so it's this big squishy kind of thing here. But the real fun stuff is actually stuff that isn't meant to actually actuate. So this is actually a prototype of a little kind of tentacle finger. And so what this is the outer layer here is actually Ninja Flex. And all these horizontal slats are all PLA or ABS. It can be anything rigid. But the idea is that generally you can move this thing, it's kind of like a tentacle, just move it left and right. But when you put an obstacle in front of it, so like this electrical tape, with a small actuation, it will actually contour around neatly whatever obstacle you put in front of it. So it's really cool. This basically works on a simple mechanism, kind of like a 4-bar. You have, you know, it's like you have two angles and kind of make a parallelogram. These have tapered sides. So if you separate one of these sections, you can kind of see this tapering on this side is smaller. And so it forces it to kind of go at this weird angle when it rotates, and they just kind of stack these. So you get this interesting movement. It also can kind of bear weight if you were to hold something on top of it. It curves by itself and doesn't droop or anything like that, which is really neat. But I'll be working with this and my EMG sensors that I was talking about the other week to kind of make some robotic grippers and things like that with some really kind of alternative, interesting prosthetic stuff. So that's what I have for this week.
Is there a name for that tapered gripper? Is there like a mechanism name?
Not that I know of. This is something I was doing a lot of research. There's this really cool robotics company somewhere in Europe called Festo.
Yeah,
and
Festo.
They make really cool like robotic animals and things like that. So I was looking at their elephant trunk video for a while, and I kind of replicated some of those things, but on a desktop 3D printer instead of, you know, research lab land.
Yeah, they make like hydraulic fittings and like manta rays.
Yeah, and like flying helium-filled penguins and jellyfish and kangaroos and all cool stuff. But you know, it just kind of a really cool thing that you can kind of make some of these more advanced things that people are doing in research lab just, you know, in your basement at home. So.
All right, thank you so much for coming in and showing that stuff. Please come back with more, and of course,
absolutely.
As you know on the show, told sticker, email support@adafruit.com. Next up, Adam. How's it going, Adam? Unmute your mic and show us your project.
Today, well, I got this in the mail today. It's the Adafruit. I got an Adafruit package, and as soon as it was pretty exciting. So as soon as I got it, I of course started working on my project, which it's kind of a motion sensor for my room. It's not exactly finished yet, but I actually do have a prototype. And also another thing I've been working on is my desk.
Ooh, that's nice.
Yeah.
I like the nice cube tray as parts holding. That's a good idea.
Yeah. I kind of got that from Becky Stern's desk.
Cool.
So basically, I'll try to get this. I'll have to. Okay. Let me see if it'll work. Takes a little bit. Okay, there it went.
You're a detective.
And I got the button to light up also.
Yeah.
And I bet I could get it open, but who knows? It's just a big mess of wires.
Okay. This is a great project.
That's cool. And you just built this today?
Yeah, I just built it in like 2 hours or 3 hours.
Perfect timing for the show and tell.
Yeah.
Awesome.
All right, not too bad. You did the live demo, so you definitely get an As Seen on the Show and Tell sticker, and you got plenty of room on that for it. So make sure you email support@adafruit.com. And thank you for the order.
Okay.
It's a great looking. I like the block, and it's
Yeah.
got like a red LED button.
Nope, I think you cut out there. Okay.
Thank you, he's gone. Okay.
All right, next up we're going to do Gregory and then Marcel. So if you guys can keep it to like 2 minutes each.
Hey, Greg.
Hey, Greg, how's it going?
Hi, how's it going?
Good.
Okay, 2 minutes. Holy crap. All right. So, I know. I did the helmet last time. This is it here. You saw that.
Yay.
What I have for you today, and I don't know if you can see everything here, is if you remember the first time I came on, I had that little Raspberry Pi thing inside of this box. So it's all set up now, and I actually have. Okay, Leo, let me just slip into this thing.
Whoa.
Make yourself comfortable.
It's like a
Alright.
monitor.
I'm sorry, what did you say?
This is an intense vest. You have like a monitor sticking out of your
Alright, so I don't know if you can see this, but I wrote a Python program for onboard keys. I've got a GPS location there, and I wrote another program for XP messaging. So I can now see location data of myself. I can control with on-screen buttons because this just does. You can't like zoom in or anything because this isn't a pinch screen. It's an Adafruit 7-inch TFT. But yeah, so you can't do it. So I had to write some buttons with UInput and XP messaging application so I can send messages back and forth. And so that's set up, and I have this little project I'm going to show off later. Don't know if you can see that. No, probably not.
I can see the breadboard.
There's an LCD.
Yeah, it's a liquid crystal with a GPS module and a God, what's that thing called? Arduino. There we go.
Yeah.
And an Arduino, so I can.
Don't worry, they're changing the name. It's Genuino now here now.
Yeah, the objective is to be able to get location data of other people, as I said, and display it on this map. So things are coming along. But in the interest of time, I'll save the Arduino one for later.
Yeah, will you come back next week?
I hope so.
Okay.
I have finals next week, so.
Okay. All right. Well,
very distracting.
well, good luck with the finals, and I like how you're kind of taking that cyber officer theme to the map. Very good.
Awesome. All right. Thank you, guys.
All right, Marcel, unmute your mic and show us your project.
Yeah. Okay. Hello. So I wanted to show a little update on the milling machine that I've shown a couple of weeks ago.
Okay, great.
Well, one of the problems I had that the stepper motors were not really strong enough to move the XY table, and so I put some gears on it. So I didn't want to buy bigger stepper motors. I wanted to use the ones that I can readily available at the hobby shop. Those that are often used in 3D printers. So you can see it. So here are the. This is what I did with these gears, so now it runs a lot smoother. And I also made a control box with the electronics.
Oh, that's great.
it's a Raspberry Pi in the back, and with a stepper driver shield on top of it. I made that myself. And here is the over-the-top amp meter.
Yeah.
So I'm thinking about, so this was just for fun, but I'm thinking about putting the display, which is now separate, where you can see the control of the. This is written in Python, and I want to put a display in this box.
Okay.
So probably one of the displays that you guys sell. I want to look for one that fits nicely in this box. So this is the control software. You can actually see the G code.
Yeah.
That's running, and you can also jump between lines while it's running. So
that's nice.
you can repeat certain parts or use it with different settings and so on. Yeah, so one of the things I made with it, so I got your sticker when I showed it last time. It was really, it was less than a week, so it's quite impressive to Europe. It was really cool. And when I received it, this is what I made with it.
Oh wow.
Ooh. That's nice.
That's not what we sent you. You made it way better.
Yeah. So here.
You cut that on the CNC?
Yeah. Yeah, I made a photograph of it, and then I sent it to this machine just to see if it's just to check if everything's working. And the printed circuit board, which contains the SMD LEDs, is also made with the milling machine.
You're like a full factory.
All right, Marcel. Well, you and your show and tell get to show and tell on the show and tell sticker. Show and tell. It's show and tell stickers all the way down.
Yeah, that's cool.
All right. Well,
Very nice. So that was it.
All right. Yeah, come back as you do get another show and tell sticker. Email support@adafruit.com. This time, make another thing out of another material.
Yeah. Okay.
That's a challenge.
Yeah, I'll try.
I'll keep sending stickers if you keep making show and tell.
Okay.
Stickers.
Thanks.
All right.
Yes.
Thank you so much, everybody. We're here every single week, 7:30 p.m. Eastern Standard Time. Next week we will not be though. Next week we have off because we have a bunch of things that we have to do that happens to happen right around this time. So we will not see everybody next week. We'll see you the week after.
That's kind of perfect, actually.
Yeah.
You guys get a break.
Everyone gets an extra week to work on your projects.
Okay?
Good.
Tony, thank you,
Whoa,
Pedro.
Tony's cat's creepy looking.
Hello.
Whoa.
Thank you, Marcel. Thank you, Greg. Thank you, Chris. Thank you, Alex. Thank you, Adam. We'll see everybody in 2 weeks, and we'll see you on Ask an Engineer in 5 minutes.
Carmen's cat's freaking out.
Not freaking.
What are you looking at, Carmen?
Us, our souls.
He's gone.
Mer.
Okay,